Hello guys, welcome back to the channel. And so in this video we will talk about dynamic programming. So dynamic programming is an algorithm technique which is used to solve the problem which satisfy these two properties. So we will discuss these two property, that is overlapping subproblem and optimal substructure one by one. But let me give me an idea that what we do in dynamic programming. So in dynamic programming we have given a problem. So we assume it as a large problem, and then what we do in the dynamic programming is we divide the large problem into a sub problems, and then we build the solution for the sub problem. That is, we find out the optimal solutions solution for sub problem, and then we use them to build. Then we use them to build the solution for the large problem. Build the solution for large problem. We have discussed this technique somewhere also. You can guess it. We have discussed this type of technique in divide and conquer technique when we talked about the merge sort and quick sort. But there is a difference between dynamic programming and the divide and conquer technique. Uh, Instead, we are dividing our problem into the sub problem and then finding the solution for the sub problem. But in divide and conquer, these two properties is need do not need to be satisfied, but here this property should be satisfied. So in overlapping subproblem, uh, eh, eh, we say that overlapping subproblem property exists when there exists a repeated subproblem of a large problem. Then what we do, if there is a repeated subproblem of that of the original problem, then what we do is we need to solve this only for one time, and we use that solution for uh, when then we use that solution if any other time that subproblem exists. And in optimal substructure, we when we divide our problem into a subproblem, we solve this subproblem same as we are need to solve this large problem. uh, this subproblem is same as the large problem, but but only difference is that this is a large problem, and we have reduced the parameter to in subproblem, but the problem is remains same. So if large problem, we are finding the solution for the large problem which is optimal, then we can say that the large problem which is consist of the many sub problems, then the sub problem is also having the optimal solution. So what I want to say is, when I will discuss the example, then you will uh, definitely understood the properties. So let's discuss the properties one by one. So first is overlapping subproblem. So let me take an example of Fibonacci sequence. So I hope that you know what is Fibonacci sequence. So in Fibonacci sequence, we need to find out the range of numbers such that number is any number is sum of sum of its previous two numbers. What I want to say is, first number in the Fibonacci sequence is 0, and then 1, and then we find out third number in the sequence, then it will be the sum of its previous two number, which will be 0 plus 1 will be 1, and then 2 will be then fourth number in the sequence will be previous two numbers sum, that is 1 plus 1 will be 2, then 1 plus 2 will be 3, so and so on. So this sequence goes on. Okay, so this is called as a Fibonacci sequence. So this can how you will solve this problem. One way to solve is recursive way, such as we can find out if we want to find out the, let's say we want to find out fifth Fibonacci sequence, fifth number in the Fibonacci sequence. So how we will find out is, we what we will do is, we will recursively call fib of uh, that is 4 minus 1, that it will be sum of the previous two numbers. So 5 minus 1 is 4, and then 5 minus 2, which will be 3. Okay, so we will solve this. Then we will recursively call the fib 4. Uh, then it will be fib 3 and fib 2. Similarly, fib 3 will be fib 2 and fib 1, and then fib 2 will be fib 1 and fib 0. Okay, and then fib 2 will again be fib 1 and fib 0, and then fib 3 will be same as this. Okay, so when we do not use the dynamic programming, then we solve each of the recursive call, and its take order of 2 raised to power n um, time. So it is a exponential time. So we do not want to find the solution in the exponential time. So we use the dynamic programming here. So how these two properties is satisfying here is, so uh, first property was overlapping subproblem. So overlapping subproblem is, I have discussed here that when there exists a repeated subproblem. So what is the subproblem is, we have divided our fib 5 sequence into the fib 4 and fib 3, and then fib 4 divided into the fib 3 and fib 2, and so on. Okay, these are the all subproblems. So we can see that fib 3 is occurring two times here. Okay, same problem is existing two times. So instead of solving this two times, we can solve this only one time, and we can save the solution for this solution. And then later when we will come here, then we, instead of solving all the instead of dividing this into the further sub problem and again solving it, we can use the solution for this f3. Okay, so similarly, you can say fib 2 is repeating here, and fib 1 is repeating, fib 0 is repeating. So this is called the overlapping subproblem. Okay, and the second property is called the optimal substructure. So we know that we discussed that the what is Fibonacci sequence of any number. So it is nothing but the sequence of it is the sum of the previous two numbers. So it will be n minus 1 plus Fibonacci of n minus 2. Okay. So when we talk about this problem and this problem, this problem consists of the sum of these two subproblem. So when we solve fib n minus 1, so it will be this problem is of same type as this fib n, but only difference is only the parameter. Here we have finding the solution for n, and here we are finding the solution for n minus 1. But how, the way in which we will solve the fib n, uh, the same way we will solve fib n minus 1. So fib n minus will be the same as fib n minus 2 plus fib n minus 3. So we are approaching the problem solution of the problem in the same way. So when solution of so when we find out the fib n minus 1 and fib n minus 2, then we if these two having the optimal solution, then the large problem will also have the optimal solution. So this property is called as the optimal substructure. Okay, so or we can discuss one more example if you didn't understand the optimal substructure here. So let's say we have given a graph. Okay, we have given a graph. So S P, these are number of nodes. Okay, so we have to find out the shortest distance. We have to find out the shortest distance here. So what will be the shortest distance here? So we can find out the shortest distance here by what can be, there can be many ways. Okay, there can be many ways to solve this problem. For example, if S is our source node and D is our destination node, then we can reach the destination node from S via this path, but this will consist of the three edges. We can also reach from this path. This is also consist of the three edges, and, and then similarly we can also reach through this path. Okay, so this consists of the two edges only. So this will be the shortest path from S to D. Okay, so how we have reached from S to D? We move from S to D and then D to D. So this consists of the two problem. First we have reached from S to T and then T to D. So S to T, when S to D is optimal, if it is optimal, that is, it is shortest path, then S to T will also be optimal. S to T and T to D, S to T and T to D will also be optimal. So, so this, so this is called the optimal substructure. If large problem is satisfying the optimal property, then its sub problem will also be will also follow the optimal property. But let's say if we discuss about the longest path from the source to destination, then what will be our answer? So let's say what will be the longest path here? So longest path can be, uh, let's say if we have this number of edges also, the longest path will be this, this, and this. So 1, 2, 3, 4, 5. So if we talk about the longest path from S to D, then the longest path will be S to Q, then Q to T, then T to P, then P to R, then R to T. So it will consist of the 5 edges. But let's say if we divide this problem into the two parts, let's say we are reaching from S to P, then P to D. Okay, but then this is not sure that S to P will also be the longest path and then P to D will also be the longest path. Here we have used S to P in the longest path solution. S to P distance is 3 edges. Okay, so but we can see S to P, uh, what will be the distance from S to longest path between S to P? It will be S to Q, Q to T, then T to P. It will be same as this, but if we talk about P to D, then P to D, longest path from P to D is longest path from P to D will be P to Q, then Q to T, then T to D. It is consist of the three edges, but in the original solution, this consists of only two edges. So uh, here our optimal substructure property is failed. So in this we have to check out the both the property overlapping subproblem and the optimal substructure. So in order to solve the dynamic programming problem, I hope that you understood this both property, and we will discuss the problem as well on this concept, and also we will talk about the approach that is used in the dynamic programming, which is bottom up and top down approach.